Okay, so the recording is started. What we're going to cover today is actually twofold. One is looking at the some of the geometry cleanup tips and tricks that we can do, and the other thing is to look at the some of the options that probably, if you're like me, you just kind of ignore them, but you know they give you a little more control over the hex and brick meshing options, and so we're going to talk and put some real meaning behind what those options are. Okay, so I'm going to go ahead and get the show on the road. I'm going to start by importing some geometry, and I'm going to import a parasolid file. Now, by the way, this is actually a the beginning of this is actually part of the standard exercise, except I embellish a little bit more than they do. And also the geometric portion is unexciting, not really important for what we're talking about. It's simply a vehicle really to get to the various options and explain what those options are. So I've got this parasolid built in. Now you may have noticed if I zoom in here, there's actually kind of a little triangular sliver. I can actually, as I'm rotating, kind of see through into the interior of that. So one thing some people don't realize is that a parasolid does not have to be a perfect solid. In fact, it doesn't have to be a complete solid at all. Just because you're reading in a solid, a parasolid, does not necessarily mean that you've got a good clean solid ready to go. Okay, so that's the crux of this particular exercise. We're going to go to a different part for some of the other options later on, but this will be a two-part kind of demonstration. So I've got this in, and the first thing I want to do is I want to go ahead and stitch it into a solid, because it doesn't have to be a complete enclosed solid. So I'm going to use under geometry, then solid, then stitch. And I'm going to pick everything that's here. Sorry, hit this. And hit OK. Now, you'll notice at the bottom in the messages area, it says solid 7, which it just created, passes body checking. You cannot trust that message. That does not mean that this is now a valid solid. In fact, it's even highlighting in yellow here. If I did a Control G, I could make this go away. But it's actually highlighting in yellow a problem that it has encountered here. Okay, but let's suppose we didn't see this, or we took it on its word. One thing we can do in order to check this is I can go into mass under my tools, mass properties, solid properties, and I'll pick this so-called stitch body and hit OK and take the default density. You'll notice right here at the very top of the message screen it says volume equals 0. Okay, that's a dead giveaway that you don't have a really complete solid. Okay, so keep that in mind. That's a good check to go through. So, but just for giggles, let's go ahead and do this. I'm going to go and mesh, and I'm going to say let's mesh this solid anyway, right? So I'm going to mesh geometry solids, and I'll just load in I'll just pick any material, doesn't matter. And I'm going to take the defaults. Actually, I'm going to turn off this tet sliver. I'll leave the tet sliver removal on, and I'll take it straight out of the box and hit OK. Now you'll notice something here again in the message area right here. Unable to complete tetrahedral mesh. In other words, everything you see here are plate elements. They are not solid elements at all. This is hollow. It failed. It says the surface mesh contains at least one hole, the hole being that slight sliver that we saw there. Okay, so this is not going to fly. So I'm going to undo this, Control Z, and get rid of the mesh I just made. Okay, now what we're going to do is we're going to go into geometry, solid, and for the first time we're going to look at this one at the very bottom here. It's called cleanup. So I'm going to pick this. I'm going to select all the solids, which there's only one. It's solid 7, solid body 7, which is still the result of that stitch I did before. And I'm going to turn on 3 options. Remove redundant geometry. That just means get rid of stuff on top of stuff. Remove sliver surfaces. So you got real skinny little sliver surfaces that exist. It'll kind of merge them into an adjacent larger surface for us. And then finally, just check the geometry to make sure it's topologically correct. So I'm going to turn on all three of those options, and I'm going to hit OK. You notice it says solid 7 passes geometry checking, okay? Just like when I stitched. But I'm still seeing, I'm going to zoom up a little bit, you can kind of see it rotate around, right? It's still got a gap in it. Now I could go through and do the same thing I did before, which is to do a mass property and all that, but I can tell you right now, this is not a valid solid, okay? So in the interest of time, I won't go through those same checks and mesh it again, because we're going to get the same result. So the thing to keep in mind is solid geometry cleanup is not a magic wand. It's not going to necessarily fix everything that needs to be fixed. It's going to try and maybe fail. And in this case, it failed. So what we're going to do is go into geometry, solid, and I'm going to pick a different option called explode. And pick everything, which is just one solid. And so now what it's done is it's turned this solid back into its constituent surfaces and edges. Really quick, you may or may not know that a solid is simply a bunch of surfaces that have shared edges, right? So this surface has these 4 edges, and this surface shares this edge with this surface, etc., etc. Put all those together, you have a solid. So I've exploded this. Okay, so what I can do now is I can say I'm going to go and delete this particular troublesome surface here on the front and OK it. And you can see that now I have a hollow box, right? I'm looking into this hollow box. Also, if I zoom up here, you can still see, in fact, let me do it this way. You can still see that I have 2 curves here, okay? So ideally, I want to get rid of those 2 curves. Now I could go through and delete out one and kind of run through it that way. But instead of doing that, I'm actually going to do something I've already done. I'm going to do geometry, solid, cleanup. And you may be wondering, this is part of, I think, some of the confusion. Hey, look, this is not solid anymore. I've taken a face out, right? This is just a bunch of surfaces. Well, yeah, except that it still considers this to be a solid, just like I could make a parasolid out of this at this point. So again, you got to get rid of the old notion that just because it's a parasolid or a solid, that it's actually a real valid solid. That is not necessarily the case. So I'm going to pick everything, and I'm going to turn on the same options I did before and hit OK. Now watch where you see the 2 yellow dots here, and I hit OK. See that? It cleaned that up, didn't it? Now that's all one edge. So it can be used to clean up stuff like that, even if you don't have a complete solid. Of course, now I still want to get to the area where it's a complete solid, right? So I'm going to go in to my geometry surface and make it by edge curves. So I'm going to pick 1, 2, 3, 4, hit OK, voila. But I still need to stitch this into a solid, right? So geometry, solid, stitch, just like we saw before. Select all. It's going to pick all these surfaces, and I'm going to hit OK now. Okay, so let's see if we've done any good. I'm going to go into mesh, geometry, solids, and again I'll just pick any material. And I'm going to go ahead and just take the defaults and hit OK. Voila, you'll notice down here that it's now telling us, hey, you've got a successful tetrahedral mesh. Okay, so we're all good there. Okay, everyone with me so far? Anyone not with me, go ahead and unmute and let me know. Okay, hopefully everyone's still with me.
Still with you, and it looks really good.
Okay, great. So let me hop back, and I'm going to undo this one more time, because now we're going to change hats. Okay, that was on the geometry cleanup kind of portion of things. Now we're going to hopefully demystify some of the options we have when we mesh geometry solids. Okay, now, and again, I'll just pick any material. Okay. Now, I purposely picked solids and not hex mesh solids because we want to talk about this options button. If I went in and did a hex mesh, a lot of these would be grayed out. So I want to talk about all of these. And so this is a worst case scenario. So we get to talk about each one of these boxes and mostly qualitatively, what do they mean? Okay. We'll just go top to bottom here. Now, some of these, I'm going to go to another example when we get farther down, but we can talk about some of these now. Adjust nodal precision. Okay. You can see here on the solid here, we have the mesh sizing dots, which are kind of like a preview as to where it's going to create the nodes for the elements, right? All adjust nodal precision means is I'm going to calculate wherever this node is, and then I'm going to truncate it to 6 decimal places. That's it. it just truncates the x, y, and z coordinates to 6 decimal places. So a better name for this would be truncate x, y, z location of nodes to 6 decimal places. But I guess that would be a little wordy, so they put adjust nodal precision. Okay. Now, check surface elements. And delete surface elements. I'm going to talk about these together. Now, delete surface elements is on by default. And in most cases, if you're doing brick meshing, solid meshing, you should leave this on, because the way it works, the way it creates these this mesh is, it actually meshes each of the faces, and then it maps that into the interior. Okay, that's the internal methodology. And then when it's done creating the solid elements, it then deletes these surface elements that it made as a basis for that solid meshing. Now, if you turn this off, then it will go ahead and create plate elements on the outside as well as the solid elements. So if you ever did want to have plate elements automatically on the outside of your solid model, you could uncheck that and have that done automatically for you. Okay. Check surface elements. What does this mean? Qualitatively, it means that when it's making these surface elements that it's going to then map into solids, it's checking to see all the normals are going in the same direction. You don't want to have them, some going in and some going out. It's going to check for free edges like we would have had in a sliver or something like that. So it's basically checking to make sure that everything's kosher. So, this is like chicken soup. It can't hurt. You can go ahead and turn that on, and if there's any problems, it'll come out in the status, which we'll talk about here in a second. All right. Mesh all regions, including voids. If you check this on, it's simple. Suppose this cube had a hole in it down the middle. If you check this on, it would also mesh that hole. So any voids in the solid would be filled. Okay? It's pretty straightforward. Quadratic mesher and Jacobian, I'm going to talk about later. Let's talk about this split tets with all corners on exterior. Okay, so I'm going to actually turn that one on only, and that's going to be the only thing that's going to be different. And we're going to hit OK. Now, what split tets with all nodes on exterior is supposed to do is it's saying, okay, any tetrahedron that I make, and again, this is only for tets. Any tetrahedron I make that has its 4 corners, 1, 2, 3, 4 in this case, it's supposed to split it into 2. I have never gotten this to work. In fact, I have an IR into that to find out what's going on. So this is one that I've never gotten to work, and so hopefully we'll have an answer on that. But that is, from my understanding, what it's supposed to do. Now, going beyond what it's supposed to do, why would you do it? I don't know. Obviously, somebody asked for it. I don't know the basis or the reason why you would want to do it. I just know what it's supposed to do. So keep that in mind. Let me undo this real quick. And let's go back in one more time.
Michael, a question about those options.
Yes.
The meshing to fill all the voids, is it going to put mesh around the boundary or the surface, say the hole in the block?
Right, yes. It'll follow like
Would it put mesh on?
Yes. The answer is yes. It would like follow the pattern of that void. In other words, it wouldn't look the same as me doing this cube, right?
Right. Okay, so you would see that in the mesh pattern
Right.
within the volume.
Yes, correct.
Okay, well that could be really handy. Okay, thanks.
Yep. All right. So we talked about this split tets just now. I'm going to talk about smooth. That's another model, and the Midside nodes on this. This improved collapse tets, and this is a big number, by the way, this maximum collapse ratio. Think of collapse tets as flattened. So if you look at that, like, let me pull this aside. You know, this tet we had here, I would regenerate again, but I think it's pretty simple. The tet we had right here, if you took this corner node and kind of moved it into the cube, so you're flattening that, okay, the more flat that becomes is more of a qualitative thing, but the more flat that tet becomes, the higher this ratio becomes, okay? Like 10 to 1 is pretty bad, okay? So, you know, if I was going to run this, I'd set this to 10 or something else rather than 100 and say improve it. And what it'll do is it'll look for flattened ones and try to refine the mesh in those areas as much as possible in order to get you know, better tets in that area. No guarantee it's going to do it, but it's going to try. Okay, so that's my qualitative description of collapsed tets, right? Think of a smushed, flattened tetrahedron. Okay, so hopefully that explains that. Desired edge length, minimum and maximum. So for instance, this is a 1 by 1 by 1 cube, right? So each of these is 0.2 inches, right? From this node to this node, that's 0.2 inches. So theoretically, suppose I wanted another node in between here. I'd say, you know what? I don't want you to go any more than 0.1, right? And it has to be at least as big as 0.01. So the minimum value is to prevent elements that are too small being made, and the maximum is, of course, the opposite, right? That's the biggest I want it to go. Now, if you look at the actual help file, which you'll look at in a second as well, you'll see that it actually says it will follow your desired minimum and maximums as the geometry allows. So it's kind of nebulous. In fact, you know, I happen to know if I set these and I do it, it's going to ignore them anyway. It's going to go ahead and make it bigger than the maximum. So again, is one of those things where just because it says it's a maximum, that's not a hard and fast rule. The meshing may override that. Okay. In fact, I'll leave these here, and you know it should make another node in here, right? Or another edge length. It should make another element half the size. It won't. So just be aware of that. And I'm also going to do one other thing. I'm going to turn on detailed status messages. So when we come down here, I'll show you the difference in detailed versus not detailed, okay? But for right now, I'm going to go ahead and click OK on this. Okay, I'm sorry, 10 is too big, or 10 is too small, apparently. I'll just set it back to 100. I'm not worried about that anyway, because we won't have any that are in that range. And hit OK. I'm going to turn off the mid-size nodes also. Okay, so, you know, I said the maximum length would be 0.1, but you can see it completely ignored it. So, again, if you look at the help file, it will actually say something to the effect that it won't necessarily follow the min or maxes that you put in. So just be aware of that. That's not a for sure thing. Okay, think of it like a suggestion to the mesher. Okay. Now I also turned on show detailed status messages. So let me just drag this up temporarily and kind of scroll up a little bit. And I'm going to show you the difference between, remember the last mesh? Okay, so the last mesh started here, and the data went down to about, oh, I'm sorry, gotta go back to the next one. Sorry, it started here, went to about here. When I turned on detailed, you can see that it's giving you a lot more information about the mesh quality, etc., etc. So there's a lot more information put out in your status line about the meshing and the results of the meshing when you pick that detailed status line. Okay, and I'll show you one other thing here, which has to do with data tables. So, and that's a quickie. And so if I say update data table with mesh quality, hit OK. You can see that I turned on the data tables under tools, data table, so that it appears here. And it'll show you the element that has the worst tetrahedral collapse ratio, which you can see is 3.6. It's not bad at all. And then the one with the worst Jacobian element quality. Qualitatively, Jacobian element quality is, think of it as kind of where I said tetrahedral collapse is smushing it. Jacobian quality is kind of skewing it, okay, for lack of a better term. So, but at any rate, it's showing you the worst in the tet collapse, which is element number 1542, and the worst for the Jacobian element quality, which is element number 1466. Okay, so that's all that particular thing does. Okay, so this is as far as I can go with this particular model. So I'm going to go ahead and close this, and I'm going to open a different model to kind of talk about the other ones. This is a standard one that's in the examples, but this this goes beyond any examples that are in the examples. In fact, the last one I talked about a lot more than what was in the standard exercise. So just FYI. And again, I will be posting this out to our YouTube site when we're done. So let's go on first, and let me just I'm going to delete the model itself, and let's turn our geometry on. Done here. So this is our solid model. Just before we get started, just so I don't have to keep doing this, let me just make a material real quick. Material property, and then also a physical property referencing that material. I'll just call it solid. Okay. All right, so now we have our properties. We're ready to go. So once again, we're going to the mesh, geometry, solids. Again, I'm not picking, just to let you know why I'm not picking hex mesh. I'll just pick it once. A lot of these options are grayed out, right? So by going to mesh, geometry, solids, and doing tap meshing, I can explain more of these options. It's just as simple as that, okay? So let's go into these options. So let's talk about some of the ones that didn't really make sense for here, okay? Quadratic mesher, let's start there. What that means is normally, if I zoom up here, you can see the element sizing dots. Normally when it meshes, for instance, when it's making this tetrahedron, which looks triangular on this face, it will make the tetrahedron first and then put the mid-sized nodes exactly there. Okay. With quadratic mesher, it actually meshes against the solid and then creates the element. So what that means is the placement of that mid-sized node will be more realistic, okay, to the actual model. So in other words, if you got a curvy model, check this on. Okay, simple as that. Jacobian correction, that only shows up if you're doing that. And what that means is, okay, now that I've got that, I'm going to fit a curve through it. I'm going to use this Jacobian algorithm to make it follow that curve more closely. That's the qualitative and simple explanation. Okay. Smooth solid elements means you can actually put in a tolerance. That's in conjunction with all these. Okay. And I can actually do it independently without doing the quadratic meshing. But if it's smooth solid elements means, okay, well now I have this mid-sized node, whether it be here or whatever, I'm going to be free to move it as much as I want so that I maintain the curve to be smooth and accurate to the original curve by whatever the value here, which in this case is 0.0001 in whatever units, which I believe this is an inch type model. Of course, you know that FEMAP is actually unitless, so it's units, but you get the idea. Okay, mid-sized nodes on surfaces. Also, I'd highly recommend you turn this on, which means that even though on the previous screen you saw mid-sized nodes, right? It won't actually create them on these surfaces unless you click this on as well. Okay, so mid-sized nodes on surfaces means that. Now, once you have this on, you can choose to turn this on or not. Limit mid-size distortion angle. This is a very nebulous thing. It says maximum angle is 10. So I'm going to actually switch over to the help screen because they actually do a pretty good job of explaining this. What does this mean? Let's suppose we're looking just on one side of a tetrahedral element, okay? And here's one corner and here's one corner. So if you take the standard rules, it's going to put the mid node right there in the middle between these two corners, right? So what this is saying is, hey, if I do allow you to deviate it to the actual surface, okay, how much in terms of angular deviation can I go? In other words, this is, if I had no limit, this would be the point on the surface itself, right? So you're actually moving it quite a bit. But the limit angle is saying, well, look, there's an angle between the mid-size node, the corner node, and where it is now, okay? That's the limit angle. So if this was 10 degrees and this was 15 degrees, it would only put it here. It wouldn't let it go any farther than here, okay? So in other words, if you want it to fit the surface as much as possible, and you don't care about having a limit angle here, put in a big angle, okay? And give it the freedom to go as far as it wants. If you want to limit it so that, you know, it doesn't, like you may be thinking, it's too far out of whack, I've created some with bad shapes or something like that, it doesn't look good, try limiting the angle somewhat so it's not quite getting to the surface, it's limiting by an angle. But, you know, it's kind of the thing where you're not going to know what a good angle is for any particular model. You just kind of got to experiment with that and see what works. So that's what this particular angle is. So that was kind of a wordy explanation. Is everyone unmute temporarily? Is that make sense? That explanation?
It does make sense, and the mid-side node on the geometry is very useful for us when we're doing our crack meshing in FEA crack.
Right.
That mid-side node really helps the brick elements follow the curvature when we're doing a crack mesh transformation. So this is really helpful.
Right, I highly agree. In fact, and then we've talked about everything else. Now, having said about all this, I'm going to go ahead and turn off all this stuff for the first crack, okay? Because I want to show you a before and after, okay? So I'm going to hit OK here, and I'm going to, I'll leave mid-size nodes on, but go ahead and, in fact, now I'll do this. I'll make it really worst case. I'll turn off mid-side nodes completely. Okay, and then just to make it a little clearer, let me turn off the geometry. And look at these holes, for instance, right? Look how jaggy they are, right? You can see it to a lesser extent on the slot and everything else. Let's undo that. And let's go in one more time. And we'll do a pseudo review as we go along. So I'm going to say, yeah, I'm sorry, let me cancel one more time. Make sure I want to point out that mid-size nodes is on there. I'm going to say, yes, turn on the quadratic mesher, which means that I'm going to put that middle node while I'm doing the meshing, not after the fact when I make that strictly linear element and just put it on the middle. That's what that means. Jacobian correction can just means make it follow the curve more closely. Split text doesn't apply here. Smooth, right? So say this is how much I want to deviate from the actual edge of the surface. Mid-size nodes on surfaces, you should always turn that on if you actually want a mid-side node between these, okay? Limit distortion angle, that's a I would probably leave that off most of these cases, but I'm showing you if I was going to pick any curvy solid, what I would turn on, what I would turn off, using all these in conjunction, right? You could try leaving on improve collapse. If you're again 100 to 1, you're going to have bigger problems anyway, so I'm going to leave that there for right now. I'm not going to mess with the edge length at all, okay? And then hit OK and OK. Now, just from a qualitative standpoint, again, let me turn off the geometry. Right? Look at those holes. Right? So that's a lot better than what we had before in smoothness, and you can see that all throughout here, hopefully. Right? So those would be the kind of things that I would turn on in the options in order to get the best mesh right out of the shooting. And again, that's a qualitative explanation of all those options that you see underneath that may have been somewhat nebulous before, but now understanding what they are will hopefully, again, give you a better mesh out of the chute. So that's the end of my dog and pony show, gentlemen. So you go ahead and unplug